Hello, in this video we are going to look at benzene reactions. So first of all, before we proceed into the reactions of benzene, kita kena tengok the properties of benzene. So benzene is extremely stable. This is because kalau kita tengok structure benzene, kita ada 6 carbon dan kita ada 3 double bond. Whenever you have double bond, the first bond is always a sigma bond and the second one is a pi bond. So this one is a single bond only, therefore it only has sigma bond, and this one is a double bond, it has sigma and pi bond. Now benzene is stable because there are 3 pi bonds which are completely conjugated, maksudnya dia berselang-seli. And because of this, sebab dia berselang-seli, what happened to this molecule is that the pi system, iaitu ketiga-tiga pi bond ini, dia akan combine together. It fuses to form one giant pi system that requires high amount of energy to break. So kalau kita tengok 3D representation of benzene, so setiap bulat hitam ini adalah carbon and putih ini adalah hydrogen. Kalau kita nampak there is a dotted line, okay, that represents the pi system. The double bond is not exactly localized, maksudnya double bond dia semua adalah delocalized. So it is delocalized double bond, maksudnya dia punya double bond tu tak duduk satu tempat, dia sentiasa bergerak di dalam molekul ini. And as a result, reactions of benzene cannot disturb its aromaticity, which is the conjugated system. Jadi kalau kita nak buat tindak balas dengan benzene, kita tak boleh nak kacau pi bond ni. Maksudnya kita tak boleh hilang pi bond ni, which means that unlike alkene, benzene cannot undergo addition reactions. So benzene won't undergo electrophilic addition like alkene, except for hydrogenation reaction, but this must be done at high temperature and pressure. Maksudnya benzene kalau kita nak tukarkan jadi cyclohexane, which means like this, it looks like this. So benzene H2PT, high temperature, high pressure, only then kita boleh buat addition dan kita akan dapat cyclohexane. But this is going to be very slow sebab benzene sangat stable. And this is the comparison between benzene, this is benzene, and alkene. So kalau kita tengok alkene can undergo addition reaction with bromine, and what happen is that dekat sini kita ada 2 double bond, bermaksud Br kita akan tambah 2 kali, satu dekat sebelah sini dan satu lagi dekat sebelah sini. So it is Br. Whereas when we have benzene, this won't happen, there is no reaction. Kita tak boleh nak kacau double bond ni. Kalau kita tengok dekat atas, the double bond, kita dah hilangkan dia. We already destroyed the double bond. Okay. And kalau kita tengok hydration reaction of alkene, so this is hydration reaction. Okay. So kalau kita tengok, kita akan tambah H dan juga OH dekat sini, and we get this, whereby kita add hydrogen dekat situ. This is what we added lah. This is what we added, these two, coming from the H2O. But when we have benzene right here, nothing will happen, the product is not going to be obtained. Kita tak akan dapat alcohol like this. So, that being said, let's have a look at the reactions that benzene can participate in. So, benzene can only undergo substitution reaction, ataupun nama penuh dia electrophilic aromatic substitution. So this would be the name of the mechanism, substitution. Okay, nama mechanism dia ataupun nama reaction, nama type of reaction dia secara penuh. So what happen is that we can have benzene reacting with strong electrophile, so simbolnya E+, dan apa yang berlaku adalah kita akan tukar tempat E+ dengan hydrogen dan kita akan hasilkan hydrogen plus. Dan hydrogen plus ni, it will exist as a molecule. Maksudnya dia akan ada counter ion lah. Mungkin HCl, mungkin H2O. Dia takkan wujud sebagai H+ saja. So let's have a look at the first reaction of benzene. So the first reaction is halogenation of benzene, whereby kita boleh substitute the hydrogen dengan halogen. And what we can do is kita kena reactkan dia in the addition of, this is what we call as Lewis acid catalyst. Okay, this is also the same lah, Lewis acid catalyst. Okay, so what happen is that kita akan substitutekan in the first reaction, kita nak substitutekan Cl dengan hydrogen ni. Okay, so kita nak substitute the hydrogen with the Cl. So what happen in this reaction, we add the reagent Cl2 in AlCl3 and we will get Cl. Kita dah substitute dan hydrogen tukar tempat dekat sini. And the same one, kita boleh buat substitution of Cl, but kita guna different Lewis acid, FeCl3, and kita tukar tempat Cl, okay, dengan hydrogen. Okay, so Cl with hydrogen. Okay, that. And kalau kita tengok, dia wujud sebagai HCl as a product. And the next one, kita boleh buat halogenation of benzene using Br2 in FeBr3. Kalau kamu perasan sekarang, the Lewis acid dia AlCl3 untuk Cl, FeCl3 untuk Cl, FeBr3 untuk Br. And we are always going to use this Lewis acid, these three Lewis acid, whenever we do reactions. So what happen here is that kita akan tukarkan Br kepada tempat hydrogen ini. So we swap places. Br akan pergi sini, H akan pergi dekat sini. So kita akan dapat Br dekat sini, H dengan Br lagi satu. So this is HBr and Br. Okay, so this is how we get halogenated benzene. Now the second reaction that we can do is called nitration of benzene, and this is a fairly simple reaction di mana kita substitute H dengan NO2, the nitro group. So what we need to use is concentrated HNO3 in concentrated H2SO4. Kita mix this all up together at 50 to 55 degrees Celsius, and we are going to get this kita akan dapat this nitrobenzene. So this is a nitrobenzene. Okay, so this is the nitrobenzene. And kalau kita tengok HNO3 ni, NO ada 3 oksigen. Okay, NO3 dia jadi NO2, baki tinggal 1 oksigen dan 1 hydrogen. Kita ambil hydrogen, kita dapat H2O. So this is the only reaction that you can do. There is no modification of this. So senang saja. Basically this one you can just memorize straight away. And the third one is Friedel-Crafts acylation. What happened is that we substitute the hydrogen with acyl group. And acyl group is this thing right here. Okay, whereby R can be any alkyl group. Okay, so kalau kita tengok, kita akan guna Lewis acid yang sama seperti tadi, FeCl3 or AlCl3. And what happen is that kita akan ambil RC double bond O tukar tempat dengan hydrogen. So we get this. So bersambung dekat 1, 2, bersambung dekat 1, 2, dekat 1 ada O, 1 ada O, like that. And Cl yang kita buang ni, we are going to get the hydrogen. So for example, R, it says here, R can be any alkyl group. Contoh kalau kita guna, so the R here is 1, 2, 3, 3 carbon chain dekat R. Bermaksud this is propyl group. So what happen is that number the carbon 1, 2, 3, 4. Okay, remember that the R is here. This is the R, tak termasuk carbon yang sini. Tapi bila kita kira total carbon ada 4. 1, 2, 3, 4. Sebab tu R dia tadi saya sebut propyl. So now 1, 2, 3, 4. Sambung 1, 2, 3, 4. Dekat nombor 1 ada double bond O. 1 ada double bond O. And we are going to get this product right here. And we are going to get HCl as well. Sebab kita buang Cl. Okay. And another example is we have this compound right here. This is the acyl group. The whole thing is acyl group. So kita ambil, kita gantikan tempat hydrogen. So that is the acyl group like that. Okay. So pretty straightforward. Another way to view this would be, kita boleh fokus dekat yang ni, kita lukis semula, lagi senang. Okay, so we draw the compound again, double bond O, tapi Cl kita tukarkan dengan benzene. This is the same product as that, like that. These are the same thing. Kalau kita pusing-pusing, dapat benda yang sama. Okay. Now, the last reaction that benzene can participate in is called Friedel-Crafts alkylation, di mana kita gantikan hydrogen dengan alkyl group straight away untuk buat alkyl benzene. And looking at this, kita boleh guna chloroalkane ataupun bromoalkane, di mana R can be any alkyl group. So kalau kita guna Cl, kita akan guna AlCl3 or FeCl3, whereas kalau kita guna Br, kita akan guna FeBr3 as the Lewis acid. So if we look here, okay, looking at this structure right here, okay, kita gantikan R, ganti di tempat dengan hydrogen. R tukar tempat dengan hydrogen ni. Okay, kita just swap places. So let's have a look at example using an actual structure. So dekat sini saya ada 2 bromopropane. So this is 2 bromopropane. Okay, so 2 bromopropane. So what happen is that kita akan putuskan bond yang ini, which means that kita akan sambung dekat carbon nombor 2 from the benzene. So draw the benzene again, sambung dekat nombor 2, atas dia 1, bawah dia 3. And we are going to get the structure. And the second example, I have benzene with 2-chloro-2-methyl propane. So again, kita akan buang Cl. Okay, so kita akan sambung dekat carbon nombor 2, which means that kita sambung dekat nombor 2. Nombor 2 ada 1, ada 3, dan dia ada methyl group. And we are going to get HCl. And another one is chloromethane. We substitute with the hydrogen. Kalau nak tunjuk hydrogen dia pun boleh. So what happen is that we take this one carbon, we place it there. So we get this one carbon right here. Kita dapat HCl as the product. And again, showing this example again using a different way. Lagi senang kalau kita fokus dekat haloalkane itu. So kita ganti dekat sini, AlCl3. Kita lukis semula haloalkane ni. Ada sini tadi ada Cl. Sekarang Cl ni digantikan dengan benzene plus HCl. This is the same thing as that. Okay, 1, 2, 3. 3 ada methyl, 3 ada methyl. They are the same thing. Okay, so this is just the reactions of benzene. And there are 4 reactions of benzene that we have seen in this video. The first one is called halogenation of benzene, whereby kita akan pakai Lewis acid sebab benzene tak boleh nak halogenate macam biasa. Second one is nitration of benzene to produce nitrobenzene. The third one is Friedel-Crafts acylation to produce ketone. Okay. And the last one is Friedel-Crafts alkylation to produce alkyl benzene. Okay, so that will be all for this video. Thank you very much for watching.